How do we determine cis, trans, isomers? So isomerism or isomers. Well, let's take some pentene structures. So pentene is 1, 2, 3, 4, 5. So this is pentene. You could say one pentene or pent 1-ene or 1 pentene. And then what you'd want to do is you want to look at the first carbon of the carbon-carbon double bond, and you would want to draw in the two hydrogens that you don't see, and then you would ask yourself, what two groups are attached to the carbon of the carbon-carbon double bond? And so in this case, it's hydrogen and hydrogen. So if they're the same, then they have no cis and no trans isomerism. So if you get a compound, and you don't have to go to the next one, if you get a compound like this, okay, so we'll learn that this is named 1, 2, 3, 4. So that is, it's going to be 2-methyl but-2-ene. And we have to decide if we have cis-trans isomerism. So you go to the first carbon of the carbon-carbon double bond and you say, what are the two groups? And here you have a CH3 and a hydrogen. So you can draw the hydrogen in there. So you have a CH3 and a hydrogen. These are different. So if they're different, then you got to go to the next carbon. So this is the next carbon, and you see that you have a CH3 and a CH3. So those are the same. So no cis and no trans isomerism. So you don't have to worry about putting cis and trans in the name. Okay, so let's go to another one. Okay, so something like this, you could say, okay, we have 1, 2, 3, 4, 5. So this is 2-pentene, or you could say pent 2-ene. Do old school or new school. And then you want to go to the first carbon of the carbon double bond, and then you want to say what two groups. And so when you go to this first carbon, you see that CH3 and a hydrogen. So these are not the same. So they could have cis and trans. So then you want to go to the next carbon, and you see that it has a CH2CH3, which is an ethyl, and then a hydrogen. So those are different. So we are going to have to say whether this is cis or trans. And so then you're going to use the nomenclature rules of, and so like look at the first carbon here, the red carbon. H has an atomic number of 1 and carbon has an atomic number of 6. So 6 is bigger than 1. So this is going to be your number 1 priority. So this will be number 1 priority, and then the hydrogen would be 2. And then you come over to the other carbon and you say, okay, carbon has a atomic number of 6 and hydrogen's 1. So this is going to have a 1 and this is going to have a 2. And then you look to see, oh, the 1s are on the opposite side. So this is going to be trans. And when you do the nomenclature, that is E. And so this will be E. I think of like my name, Elizabeth Thomas, right? Or ET. So E is trans, and that would be, you would have to put E in front of the name. Now, since you only have one double bond, you don't actually have to specify that this is 2E, but you can. And so, and if you have a cis, then you would, so a cis would look like this, which is pent 2-ene, and then you would go to the first carbon and you would see that it has a CH3 and a hydrogen. So those are different. And then you would go to the next carbon of the carbon-carbon double bond. You would see that this also has a hydrogen and CH2, CH3. So those are different. And so then you would want to give them their priorities. So hydrogen has an atomic number of 1, carbon is 6, so that would get the 1. And this would get a 2 in the priorities. And on the other side, hydrogen would get the 2 and the carbon would get the 1. And you see the 1s are on the same side. And the same side is going to be cis, and cis is Z. So then you could put Z in front of the name. And since there's only 1, you don't have to put that it's 2Z, but you can if you want.